Hey everyone, this is Dr. Walker and this is video 89 on wave interference. When waves combine, we call this interference. So interference is defined as the combination of separate waves in the same region of space to produce a resultant wave. We can see here the ripples of water that when they are in the same space, that they do interfere with each other. How do they interfere with each other? They obey the superposition principle. This says that the resultant position of traveling waves that combine is the sum of the positions due to individual waves. Let's look at this picture that shows two pulses traveling towards each other, y1 and y2. As they get closer to each other, you can see that the heights combine, positions combine. When they meet, peak to peak, we can see that we have a maximum amplitude. And then as they keep traveling past each other, they're going to pass through without being altered. Because now that they've passed through each other, y1 is not at the same location as y2, so they don't affect each other anymore. There are two types of interference. The first one is constructive interference. This happens when the waves that combine have the same displacement. For instance, consider this blue wave. It has here a displacement that is upward. Consider that it's combining with another identical wave. We can make it a green wave, but let's say that it's identical. So at this position, both the blue wave and the green wave have displacements that go up. So when they interfere, they're going to interfere constructively, and the combined wave will have a greater amplitude. As you can see, the red one here is the combination of the two. Now, this particular picture shows waves that are in phase. When waves are in phase, that means that they reach their maximum at the same time. They reach their minimum at the same time. So they're going to have the same frequency. When this happens, you get the maximum possible amplitude, right? Because the peaks interfere and the troughs interfere, and you get a wave that has a big amplitude. The other type of interference is destructive interference. This happens when the displacements are in opposite directions. So in this case, we have a blue wave that has a displacement upward here and a green wave that has a displacement downward. So they're interacting, and those displacements are going to result in a wave that has a smaller amplitude. In this particular picture, it shows waves that are 180 degrees out of phase. This means that the peak of one wave lines up with the trough of the other wave. When this happens, the waves are completely going to cancel, as shown in this picture. But in general, the waves do not have to have the same frequency, the same amplitude. They don't have to be perfectly in phase or perfectly out of phase. So in general, your resultant wave is just going to be a combination of constructive and destructive interference. We can see the blue wave here and the green wave. They actually do happen to have the same frequency here, but they're not in phase. They're not out of phase. They're 60 degrees here out of phase. And so in some parts, like right here, they both have positive displacements and the resultant is a bigger wave. But in other parts, like right here, see the green wave has a positive displacement, but the blue wave has a negative displacement, and they interfere destructively. So in general, when waves combine, you could get some very intricate patterns. We're going to discuss standing waves that are a result of interference. There's also beats, which are a really good application of interference of waves.